Hello everyone, my name is Tran Duong. In this video, I will briefly explain the concept of demand paging in the modern computers you are using. This is a computer you use every day. The most obvious component is the computer screen monitor. Monitor is used to display information from computer to the user. Although it's a component you see daily, the monitor is simply a peripheral device of the computer. The actual computer is inside the slim box next to it. While this box contains many components that make up the computer, in this video, I will only discuss the two most important components. The most important component is the central processing unit, abbreviated as CPU. The CPU performs the computer's processing tasks. It's mounted on a motherboard and is usually hidden under a heatsink, making it difficult to see. The second most important component is the main memory. Main memory temporarily stores instructions and data necessary for the CPU to process. It resembles a ruler, similar to those you use in elementary and high school. During operation, the CPU and main memory work closely together to solve the user's problem. In this video, we're not focusing on the CPU. We're focusing on main memory. Simply, memory is a continuous sequence of data units, each with its own address. It's like a road. The data are the houses, and the address identifies where the house is located. Let's assume main memory has a maximum of 8 addresses, from 0 to 7. If you have basic computer knowledge, you'll know that data is essentially a sequence of binary digits 0 and 1. However, for simplicity, I'll use the page unit for data. Pages are a common unit used for memory management today. Okay, now imagine you want to play a game on your computer. First, the game source code needs to be loaded into main memory. For example, this game fits perfectly into 4 consecutive pages with addresses from 0 to 3. The CPU will read each data unit sequentially to process it, allowing you to experience the game smoothly. But I know, if you play games, you also frequently listen to music, right? Okay, let's continue loading the source code of a music player application into main memory. This music player application fits neatly into 3 consecutive pages, with addresses from 4 to 6. And simply, the CPU will read each data unit sequentially, allowing you to listen to your favorite music. Here, I'm not illustrating loading each page sequentially, but only illustrating loading up to the last page. However, the idea remains the same, loading each page sequentially. Okay, let's continue. I understand you. You not only play games and listen to music, but you also chat with your friends, right? So, let's load the chat application's source code into main memory. Oh no, main memory can't hold the entire source code of the chat application. You can't chat with your friends anymore. But wait, remember, at any given time, the CPU only needs a few units of data, not the entire amount, right? So, let's load the source code into main memory using a different approach. Just load the data necessary for execution at the current time into main memory. First, load page 0. When the CPU requests it, page 0 is loaded. After some time, the CPU needs new data, so page 1 will be loaded into main memory and provided to the CPU for processing. Continue like this until page 3. It's not much different from the approach of loading the entire game source code into main memory, is it? Now, let's continue with the music application. Similarly, its 3 pages will be loaded sequentially into main memory and provided to the CPU for processing. As before, here I won't illustrate loading each page sequentially. I'll illustrate the final result. Next is the chat application. The first page is loaded into main memory at address 7 and sent to the CPU for processing. After some time, the second page is loaded into main memory, now at address 0, overriding the first page of the game. But rest assured, Your game application is being processed on the last page at address 3, so the loss of other data won't affect your gameplay. Finally, the last page of the chat application is loaded into main memory and then provided to the CPU for further processing. By using this approach, we can load multiple applications into main memory simultaneously. This makes computers even more powerful and better able to meet the ever-increasing demands of users. This approach is called demand paging. Thank you for watching the entire video. See you in another video.